Okay, welcome back. Hold on a second. Sorry. Oh, I got it. All right. Significant digits and calculations. So we've already talked about significant figures and just regular old numbers and measurements. But what if, for example, I asked you to take an object and say you measured the width here and you measured the length there, and I asked you to find the area. Area is length times width. So you would need to multiply those two values together. Well, how would you round your final answer? These are the rules for when you multiply, or let's say you divide. For example, if you were doing density is mass over volume. So if you divided two things, how do you round? So here's your rules. First, you do your math just like normal. Math hasn't changed. Then you make sure you count the number of sig figs in each number in your calculation. So this one would have 3 sig figs, this one would have 4. By the way, if you're not familiar or you're a little rusty on determining number of sig figs, make sure you go back and look at your notes, look at those videos, etc. You will round your final answer to the smallest number of total sig figs. So if this number has 3 and this has 4, our final answer will be 4 sig figs. 3 sig figs. 3 is less than 4. Because answers can only be as accurate or precise as the crudest measurement. It's kind of like that saying, you're only as strong as your weakest link. So you're only as accurate as your least accurate measurement. Okay, so here's some math. Grab your calculator. So math is not changing. 14.02 times 2.3901 gives me 33.5009,202. So I need to round that to the fewest number of total sig figs out of the numbers that I multiplied. This has 4 sig figs. This has 5. So my final answer should have 4 sig figs. So here they are, 33.50. Before we write that down for our answer, I have to look one beyond. I look here. Is this 9 going to round that 0 up? Yes. Maybe you remember that phrase, 5 and above, give it a shove. So that final answer becomes 33.51. The 9 rounds it up. Next one, 0.201 times 140 gives me 28.14. Let's talk sig figs. This is 3 sig figs. This is only 2 sig figs. So how do I round that to 2 sig figs? 28, because this 1 is not enough to round an 8 up. 26.20 divided by 2.45 gives me 10.6938776. How many sig figs in the numerator? 4. How many in the denominator? 3. Here are my 3 digits. I look one beyond. Is this 9 able to round this up? Yes, 10.7. The next one, 100.1 divided by 2002 gives me 0.05. 4 sig figs here, 4 sig figs here. How do I make this number have 4 sig figs? Because right now it only has 1. You can't make this 0 significant. No. How could I make it more significant? How about I just add some zeros at the end? That way I have 4 sig figs. Now you might be saying to yourself, 0.05 is the same as 0.05000. Mathematically, I agree, they are the same. But this one here shows a more accurate final measurement. 2.56 times 100.1 divided by 0.0100 gives me 25,625.6. This has 3 sig figs, this has 4, this has 3. Okay, so here are my 3 digits. Is this 2 enough to round the 6 up? No. So you write 256. And if you stop there, you haven't rounded. You've totally changed the number. You went from a bank account of $25,600 to $256. What I need to do is I need to put in some place holding zeros. I need to put in a place holding zeros in the tens and the ones place. I don't do anything beyond. Now this number has 3 sig figs, okay? But 25,600 is much closer to 25,625.6. That is rounding as opposed to truncating or just chopping it off. So when you multiply or divide, you round your answer to the fewest number of total sig figs, which is different than adding and subtracting. When you add or subtract, like let's say you are calculating the perimeter of something. So 4.5, 0.2, 6.0, 5.77. So you're going to add those up as normal, but instead of rounding to the fewest number of total sig figs, we're going to round to the fewest number of total decimal places. So looks like we have 1 decimal place, 1 decimal place, 2 decimal place, 2 decimal place. So we would round to 1 decimal place. Okay? 14.2 plus 1.735 gives me 15.935. 1 decimal place, 3 decimal place. I want 1 decimal place. Is this 3 enough to round the 9 up? No. 15.9 stays. 16.21 plus 0.543 gives me 16.753. I want 2 decimal places. 16.75. 120 minus 85.5 gives me 34.5. Be careful. This has 1 decimal place. Technically, this has nothing in the decimal places. You might argue with me, why is there a decimal place here? Well, that's to tell you this has 3 sig figs total. But subtraction has to do with number of decimal places, which this has none. So if I'm rounding that to 0 decimal places, this 5 would round that up. You would have 35. Final answer, 201.0 minus 32.66 plus 1.30, 169.64. 1 decimal place, 2 and 2. 1 decimal place, 169.6. Okay, hope that helped.